ISO that's working on this topic. Kevin?
I'm Kevin Reese. I'm a distinguished robotic safety engineer at Agility Robotics, which was already said. And I'm the project leader for ISO 25785, which is the new standard for dynamic stability. Federico.
And I'm Federico Vicentini. I have a product safety at Boston Dynamics, taking care of our robots from the safety standpoint. On my other day job, I have the great pleasure to serve as the convener for this new group that has just been created and to host an amazing group of people committed to safety and robotics and all the ecosystem. So it's really amazing to see how much this initiative is taking steam. So it's great. It's just great.
All right, so let's get started. So we are working on a new standard that was just approved in May, and we had our first meeting that Federico hosted for us in Boston in July. And this is in ISO Technical Committee TC 299 for Robotics, Working Group 12, and the project number is 25785, Part 1. And we do hope that eventually this will be a family of standards, but Part 1 is for the individual mobile robot. So essentially, what we're talking about here are safety requirements for industrial mobile robots with dynamic stability. And we're going to tell you a little bit about why we chose those words, dynamic stability, as compared to, why don't we just call it humanoids, safety for humanoids. So Kevin, could you give us a crack at why dynamic stability?
Sure. I think today's presentations has been a great example of how nobody can agree what a humanoid is.
That's right.
So there's been a lot of talk about, so because of that, you know, it makes it really hard about, if you were to list that in the title, it could be very confusing about what actually is covered, what's not covered. And then when you think about the safety requirements for humanoids, it isn't different for other types of robots that also need active control for stability. So limiting it to just humanoids doesn't make sense. If you look at research papers that have been done as far back as in the 80s, one of the founders of Boston Dynamics, as a matter of fact. And so, you know, the term that he used, and researchers since then have been using, is dynamic stability. So it's a term of art, and it makes sense to use the term of art instead of defining a new term that people would have to get used to.
Okay. Federico, did you want to add anything more about dynamic stability? And
It is something that is really unique. That's the single most common minimum term that collectively represents a class of technology and robots. So that's the best identifier that could possibly be out there, being the common thing of all this beautiful collection of robots and examples. They are all dynamically stable, no matter the form factor, no matter the morphology. So that's the good thing about the name.
so this class of robots includes what we fondly refer to as humanoids. So includes humanoids, but it's not limited to humanoids. So it's anything that requires power to manage its stability actively. Otherwise, well, we'll talk about that in a minute. So also, we're specifically focusing on the industrial space. And maybe Federico, could you tell us a little bit more about why are we prioritizing industrial?
That's a good question. It's been a long debate among several classes of standards and domains, industrial, service, consumer. Yes, to some extent it doesn't matter, right? Because robots are robots, risks are risks. However, what we know best is our best chance to start with the right pace. Industrial environments are where we have the less unknowns, so to speak. And standards, as a matter of fact, are predefined risk assessments with the requirements. So starting with what we know to be somehow limited or constrained like semi-structured environments or limited population or certain type of working population, is the best way to set the first steps towards a more generalized approach. Probably, eventually, we'll get there, but today, the best chance to get to a thorough result is to start from what is consolidated, what we have experienced in, a footprint of products deployed already, warehouse, logistics, factories, is our playground, isn't it?
Sure is.
Yeah, okay, thank you. And then why now? So why didn't we start this standard a couple of years ago? Why don't we wait a few more years? Why are we doing this now? Kevin?
Yeah, so one of the definitions that ISO relies on is for a standard to be created is state of the art. And in order for something to be state of the art, it has to not only exist in a lab, it has to, or out as proof of concepts, it also has to be deployed. It has to be deployed enough and long enough that there's data behind it. And the reason for that is because if you were to do the standard too early, you'd make a lot of assumptions, and potentially poor assumptions, that then you have a standard out that doesn't apply appropriately. And so we're at the perfect cusp now where our, sorry, I got a lot louder.
It's all right, go ahead.
So we're at the perfect cusp now where the technology is far enough along, but not so far along that there isn't enough guidance out there for us. And so I think we're at the perfect spot. You know, if we waited longer, it'd be harder for manufacturers to deploy their robots.
Yeah, and just want to point out that the reason why we have these, the bottom few pictures have the little cross out is because those are service robot applications. So we're talking about industrial environment applications, the layers above, and not the ones on the bottom. So anything else?
It doesn't mean that they're not great or
Right.
they are not present as examples of a present or future perspective. It's simply, it's much harder to represent them in a standardized way because commercial spaces, public spaces, households are simply too complicated to solve at the same time. And it doesn't mean that they're not viable, they're not promising, they're not great. It's simply, it's staggered in time. And the now is true for industrial robots or service robots, but the now is, the important thing, as you said, is to act a long way, in parallel with the progress of technology. That's the key. That's the key thing, regardless of the domain.
Yeah.
And I would say if you're familiar at all with our sort of flagship safety standard, R1506, 10-18, for the arms, or manipulators, that is where a lot of our committee experts originated. And that environment is one in which, as Kevin mentioned, it's at least semi-structured, and the workforce or the people exposed to the hazards of the machinery can be trained. So they're adults, healthy, working age, working capable adults. And so we don't have to be concerned about interacting with someone out in the public who, you know, a toddler or someone who would struggle to recognize a risk or get out of the way of the robot when it was moving and so forth. So that's another part of the reason why the industrial space. So, okay, great. Well, thank you both. Those are good points. So let's talk now about what are some of those challenges and hazards. So go ahead, Kevin. What are some of the challenges?
Yeah. So this is my favorite slide to talk about because it's a perfect example. We've kind of been skirting around the issue of why safety's hard for a humanoid. And so on the screen now, you have a statically stable robot on the left, which means that in the absence of power, nothing really happens. And on the right, you have Digit, And if power is removed, this is exactly what happens. The robot falls down. And the reason that that matters is because for functional safety, traditionally, the safe thing, if there's a fault in the safety device, is for it to turn off the power. Well, for the robot on the left, it's not an issue. You aren't creating new hazards. But for the robot on the right, you are creating new hazards. So then how do you address those? And what is the appropriate way of getting to acceptable residual risk?
Yes, in fact, as dynamically stable robot manufacturer, we are obsessed about false, right?
Yeah.
So we talk about false all day long. It's our favorite thing. There are many challenges, so many, too many challenges, but if I had to pick one, I would say that for a safety standard, the challenge for a safety standard is to set and discuss the best way to fail and to set requirements about that. Because it is a true fact that this class of robots are different from, uniquely different from other classes of robots, specifically for the fact that at any given moment, there is a residual risk that is different, larger than what could be in response to safety measures for other robots. So the residual risk is the amount of risk that remains active and people are exposed to that residual risks, those residual risks after that protection measures are taken. So they're not completely eliminated. That's not possible. There is a fraction of that. For dynamically stable robots, that residual risk is larger, it's bigger. That's the challenge. So define how big is that risk is the key point. And why do we have those residual risks? Because in this space, we have uncertainties and complexities for these robots. Take manipulation. Manipulating, touching objects while keeping the balance. The links are all active together. So if they need to do both, the magnitude of the complexity of the task at hand becomes simply much larger. And at the same time, even with a perfect controller, you will have something eventually failing more often than what happens for other robots. So the key point for a safety standard or the challenge is to get those complexities and uncertainties somehow measurable, quantifiable, and then incorporated in a body of knowledge, which is the standard itself, so to be a reference and to be translated into requirements so that can be verifiable, or they could be a sort of mutual understanding and contract between multiple parties with the same common understanding of what those acceptable level of risk reduction and residual risks need to be respected. That's the challenge, is the key idea of having something measurable and agreed upon. It's very lofty, but we get it.
And Federico, you just mentioned that the body of knowledge, collecting it in this document that we call a standard. So can you tell us a little bit more about, what do we mean by a standard, a voluntary standard, and what would be some of the alternatives? Why are we doing a voluntary standard in this project?
Oh, that's a good point for the inside of how standardization bodies work, because it's a group of people with different backgrounds and different perspectives, bringing together experience, their take on the state-of-the-art perspective, subject matter expertise. This body of knowledge is how can we anticipate in a standard what is foreseeable to provide requirements for what must be done to reach the target, which is deploy safe robot. So the body of knowledge is building up all the experience and condense that into a document that has a list of requirements to benchmark it. Those are targets. They're not design solution. If truly bad standards will be to dictate in a prescriptive way how to solve the problem. The standard is, this is the problem, this is the target to meet, go and deliver the best product you can, meeting those targets. Agreeing upon what are the targets is the key element in the standards. So that's the goal. That's our goal as a community, to come up with a consensus-driven set of targets to agree upon in a broad sense.
And so, why do you think we couldn't just have a white paper, or why do we think we don't want to just let each country set their own legal and regulatory requirements? Kevin, what do you think?
Yeah, so in the lack of having a machine-specific standard, which is what we're trying to accomplish with this standard, you would have to fall back on, this is an ISO standard, so I'm going to talk about Europe specifically. And so you'd have to fall back on the machinery directive and the future machinery regulation. And then you would have to prove how you're meeting the safety, each individual company with each robot that you have. And so having a machine-specific standard, like this dynamically stable standard, makes it a lot easier, because once it's created, you have a framework of how to meet the machinery directive and the machinery regulation. And it makes it easier for manufacturers, end users, and the assessors that'll be evaluating your equipment in order to show that you're meeting the standard. And then so you asked about the white paper. A white paper can give some guidance, but it doesn't really help you with your declaration of conformity, which is why you would create a machine-specific standard.
So the white papers don't contain requirements. They contain advice, but they don't contain requirements. So, yeah. Did you have anything else to add to that, or?
It's important to use every element of knowledge and contribution to the field, but there are some, lighter sources of information and stronger sources of agreement that can be used to set a solid ground for taking initiative, for to base a go-to-market strategy, and so forth. Standards, of course, provide one of the strongest approaches. So that's the reason why I'm not denying that there is value in any other form of talking about safety. We love to talk about safety, right? All day long. But standards are one of the most powerful tool in the toolbox.
And I will just say briefly that at 8.3, our standard strategy has long been to do the work first in the international sphere, which in our case is ISO, and then countries around the world can nationally adopt that ISO standard and bring that into their own regulatory environment. So that's, for example, what we've done with ISO 10218, bring it back as R1506 to the US, which is consistent with Canada's Z434 and other 10218 based standards around the world. And so that's what we're hoping to do with this standard. So when this standard is published, then we will be able to nationally adopt it. And essentially all countries around the world that nationally adopt it, the rules will be the same. And so I'm sure you can all see how that's beneficial to industry, to have a consistent set of rules around the world in multiple different markets. So speaking of when it's going to be published, maybe Kevin, as the project lead, you can tell us a little bit about what's our plan? What's our plan between now and publication? How are we going to get there?
Sure. So we got approved to create the standard in May of this year. We had our first meeting in July, and we also release the working draft at that time. And so we're currently in the stage where we're refining the working draft, heading towards a committee draft. So we're trying to define all the technical content that needs to be put in. This is where like the hardest year is what happens. All the hard stuff has to go in right now. And then beyond that, we'll get comments from the committee draft where we'll do some further refinements. And then at each stage, you get more consensus and less technical content added. And so after the CD stage is the draft international standard, and then the final draft international standards after that. So our publication date is scheduled for May of 2028. So it's a 3-year timeline, and that's the max limit from ISO.
Yep. Okay, great. So then let's talk a little bit about who's involved in this and what this process actually looks like. Federico, can you tell us a little bit about who's involved in this working group and how people can get involved if they want to be involved?
Sure. Working Group 12 is one of the last added, as Kevin said, approved in May, in the ISO Committee for Robotics. It's a dedicated committee for robotics. And this working group is entirely dedicated to the development of this project. When we proposed that, we thought it was somehow a small group of people, you know.
Naive, we're naive.
Right, heading off to an endeavor, and it's now over 100 experts registered to that group. So the family is growing, and it's an open family, of course. National experts of so many countries. The nice thing of this group is that there is a very well-balanced composition of robot manufacturers, end users, service providers, experts, consultants, institutions. So you have all these different angles and perspectives, because one thing is to think about safety from a robot maker viewpoint. Another one is an end user have to bring this object, which is kind of, you know, unknown collection of functionalities and worries in a given location and settings, and so everybody has their own expectations. So the group is dedicated, it's collectively taking all that information. And the way this group is organized is making sure that the progress is very fast in the beginning of the stage. As we speak, we have homework teams that are willing to inject energy as we speak. They're meeting to improve the text and to bring content as much as we can, so that it can be discussed on a world stage and gather sufficient consensus to be the reference standard.
And tell us a little bit about consensus. Maybe, Kevin, what do we mean by consensus, and why does it take 3 years?
I think that's an easy thing to talk about. So in this room, we have a lot of people. How long do you think it would take for all of us to agree on just one thing? What if we have 100 things? So that's what a standard is like. You have to agree on everything, every word, every phrase. You have to make sure it's translatable. You have to make sure that it makes sense for everybody and that we're all talking about the same thing. So as you can imagine, and we only meet a couple times a year. So in between there, we have homework teams where we will talk, but there's a lot of discussions that have to happen in a short amount of time. So 3 years sounds like a long time, but when you're involved in it, it's never enough time.
Yeah. And I would say that if you look at the slide, you can see that when we made this slide about, I don't know, 2 or 3 weeks ago, these were the countries that had appointed experts. And for ISO work, the official members of these working groups and technical committees are the countries themselves. And so if you are from one of these countries whose flags is shown here, you can apply to join this working group, and you would do that through your national committee. And so, you know, the beautiful thing about ISO standards is that it does bring together all these people. And as Kevin pointed out, we have to make sure that the wording that we all agree on can be translated into all these different languages around the world, and it means the same thing. And so essentially what you've got is this entire community of people who are doing this learning, on this journey to learn about this topic and what we should put into the standard, the body of knowledge, that journey together. And then between meetings, everyone goes home to their home companies and gets more ideas. Well, what about this? What about that? And so at the next meeting, someone brings up something new, and then we have to sometimes go back and so it's iterative. And the discussion and the improvement and the polishing of the text is iterative, and so it takes a long time, but that's actually what makes voluntary consensus standards powerful, because everyone who has sat through these meetings and discussed what goes into this standard, what we come out with at the other end is something that we can all live with. All of these different interest categories, manufacturers, integrators, end users, we can all live with what's in the standard. It took us a long time to get there, but that's why voluntary standards are complied with, because people believe they're going to meet their needs. So with that, I think we've come to the end of our prepared questions, and we still have a minute and a half. So,
Woohoo, a minute and a half.
Thank you all for your attention. Any questions?
All right, that was a big download here. Over there, you're my new favorite person for asking a question before lunch. It's always brave. So, the whole audience hates you right now, but it's okay.
I'll be quick as possible. Okay. Hi, I'm Esther, and I'm from a hardware vendor company in Taiwan. So we mainly design the industrial computers within these robots. So I would like to ask, with this new standard coming in, what would be some of the requirements that we should anticipate as a hardware vendor? And what are some of the value-added offerings that would be helpful in helping the humanoid vendors achieve this standard?
Are you far enough down the road where you can take one of those or take a shot? Kevin, you got a big smile on your face. You want to take a shot at that?
My smile is because there is no answer yet, unfortunately. We're so early in the development that we're still doing fundamental ideas and we're trying to address the biggest problem at the moment, which is like, what do you do and what is appropriate for the loss of stability? And so that's like the biggest challenge that we're tackling right now. And then we'll get further down into the details as we develop.
And I should also mention that as we go on into this process, as Kevin mentioned, that there's stage gates for review. So there's CD, committee draft, DIS, draft international standard, and at each of those points, your national committees will get a copy of the draft standard at that point. And then if you're a member of that group, your national committee, you're able to see the draft and comment on it. And so those are opportunities for you to see the work in progress episodically until we get to the end. So.
There's also another important point. This is a so-called product-specific Type C standard, which is for this class of robots. So it's the go-to standard for a given type of machine. It's not broad technology or requirements that are common to different type of products. This is the entry point for dynamically stable robots. It can be connected to a number of other standards providing all sorts of technology, but this is the starting point. It's the closest to the product that is deployed. And that's a big thing, because if you are a component maker or you have exposure to different type of technologies, but this one is specifically targeted to that type of robots with limbs and legs or wheels or balancing, I think.
Yeah.
Carole, Kevin, Federico, thank you very much. They'll be around at lunch if you've got additional questions for them. Thank you, guys.